Okay, hi Eugene. So this week we're doing a different type of simultaneous equation question, but just to kind of bring back what simultaneous equation questions are, we'll take a look at one very quick one here. So if we have 2x plus 3y equals 5, and we also have 5x minus 2y equals minus 16, well, we'll be asked to solve that system of simultaneous equations. And so we can talk about them. Let's call the top one t and the bottom one b. And our system was we would try and get one of the letters to match up. So we could get the x's to match up or the y's to match up. We spot that there's a negative here and a plus here, so maybe it's best to get the y's to match up. So therefore we multiply the top by, so we're going to try and get the y's to match up at 6. So I'm going to multiply the top by 2, so I'll have 2t, and I will have 3b. So 2t, that's going to be 4x plus 6y equals 10. And down here I will have 15x minus 6y equals 3/16 is the same as 3/15 plus 3, so that's 45, plus 3 is 48, so minus 48. And then we have these two here will kill each other off. That gives us 19x equals negative 38. So therefore x equals negative 38 all over 19. So therefore x is equal to negative 2. Now, I would then consider x equals negative 2 to be a fact. So our fact is that x is equal to negative 2. So we've established this. This isn't fake news, this is genuine fact that x is minus 2. So therefore this x up here, he's also equal to minus 2. So we can now go 2 times minus 2. Can you still see that? You can. Plus 3 times y, he must equal 5. So therefore minus 4 plus 3y equals 5. So 3y must equal 5 plus 4. So 3y must equal 9. Y is equal to 9 all over 3. Y therefore must equal 3. So our answer is x equals minus 2, y equals 3. And that's how we do the kind of the standard sort of simultaneous equation question that you would have seen in junior cert. Of course, we could check our answer by putting it back into the original equation. So let's check it with the bottom one here. So let's go 5 times minus 2 minus 2 times 3. And what's that equal to? 5 times minus 2 is minus 10. Minus 2 times 3 is minus 6. What's that equal to? That is equal to minus 16. And is it equal to minus 16? It is. So we are correct. So that's how we do the standard sort of simultaneous equation. So let's take a look at something slightly different. What about if instead of this type of simultaneous equation, I give you something that looks more like this. X squared plus y squared equals 5. X plus y equals 3. So if I go back here and just compare the two, so we see that there's something weird about this one over here. Well, maybe not weird. Weird is a kind of a wrong word. But there's definitely something different between this thing and this thing over here. Namely, this guy here has these squares. And therefore our system that we used over here will not work. Let's try it. So let's try and get the x's to match up. So that means I could multiply the bottom line by x. So we now have x squared plus y squared equals 5 on the top line. And we'd have x squared plus xy is equal to 3x. And now to get the x's to kill each other off, I might do a sign change. Minus and a minus. And my answer will be, they're gone. I'll have minus xy plus y squared equals 5 minus 3x. Don't be too worried about how I kind of did that subtraction. That's not really on your course, but that will be the answer. And we spot that we still have x's and we still have y's in our answer here. Whereas if I go back to my original sum, the effect of getting them to match up was that they would kill each other off. So in this line here, we don't have any y's. Now, what's next? Sorry, yes. So that's no good. No good. So let's have another go. X squared plus y squared equals 5, and x plus y equals 3. I'm going to do something interesting here. I'm going to isolate. So I'm going to isolate an x. So, and I specifically do it in this line here. So that becomes x is equal to, getting this x by itself, well, I'm adding y on this side, so I'll subtract y on the other side. So x therefore is equal to 3 minus y. Now, that's now our fact. We know that x is the same thing as 3 minus y. So therefore, this x up here, he's also equal to 3 minus y. So instead of x, I can change that to 3 minus y. So I will have 3 minus y squared plus y squared equals 5. That's pretty cool. I think I can go to there. So that's okay. So let's continue on. 3 minus y squared. Well, all that means is that we're squaring 3 minus y. So we have 3 minus y times 3 minus y. We have to add that on to y squared, and that's equal to 5. And then to multiply two things by two things, well, we split open the first bracket, so it's 3 by 3 minus y by 3 minus y plus y squared equals 5. So that's going to be 9 minus 3y plus y squared equals 5. Okay, so maybe the kind of difficult thing there was multiplying minus y by minus y to get plus y squared here. Tidying this up, we end up with 2y squared minus 6y plus 9 equals 5. That's okay, but that's a quadratic equation. So to write quadratic equations the way we like them to be written, we should get it to equal 0. So I then go 2y squared minus 6y plus 9 minus 5 equals 0. 2y squared minus 6y plus 4 equals 0. So we have a quadratic equation here, and then we have a, b, and c, because we're going to use our quadratic formula. So a is 2, b is minus 6, and c is 4. Into the minus b formula. I'm trying to keep everything on the screen. I don't know if I'll be able to or not. Okay, so I think if I start writing here, I think you should be able to see that still. Do you know what? I'm left-handed, so I'll put it over here. So I'll kind of work kind of counterintuitively. Okay. So I then come along and I'm going to solve this equation here. And I'm going to use my minus b formula to do that. So I'm going to go with, normally we would put x equals, but we're going to be beginning with y equals, because that's what our equation is in. Y is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And so it's b, a is 2, c is 4, and a is 2. So we now have to put that into our calculator. So we go, open up a fraction, and then we go minus start bracket minus 6 close bracket plus square root start bracket minus 6 close bracket squared minus 4 start bracket 2 close bracket start bracket 4 close bracket all over 2 start bracket 2 close bracket equals. So we now have y is equal to 2, or y is equal to, so I scroll back into it, and I turn my plus here into a minus, and I get 1. So I now know that y is equal to 2 or y is equal to 1. So I'm tempted to put the lid back on my pen. However, if I go back to my original equation, I spot that there was x's and y's in the original equation. So I've only found out what the y's are. Y is equal to 2 or it's equal to 1. So if y is equal to 2, then using this line here, we can say x equals 3 minus y, but we now know that y is 2, so we can go 3 minus 2. So we can say x equals 1. Or if y is 1, then x equals 3 minus 1, x equals 2. So what we're talking about here is x is 2, y is 1. That's one answer. So that is one complete answer. These two parts to the one answer, and these two parts here are a different answer. So that is one answer, and that is another answer. So there's two answers to this original simultaneous equation question. Okay. So that's kind of the system for solving these type of simultaneous equation questions when we have squares in the question. So a big part of what you need to do is you need to identify which type of simultaneous equation question you have, and this type has squares in it. When it has squares, we isolate x and then substitute it back in. So questions on this, Eugene, are on page 75. And if you have a go at questions 4, 5, 6, and 7, that would be brilliant. Okay, so have a go at those questions. And if you have any questions, you can send me an email or contact me again on the Teams chat. Okay, thanks, Eugene.